Jai Hind, Mahesh Kumar Sharma, Assistant Professor in Department and Computer Science and Engineering. Today, I am talking about the most important topic of direct memory access. This is topic comes in the Computer Organization and Architecture for the semester 3 students. This is very important as this is the topic related to the 5th unit, in which the 5th unit is related to the peripheral devices. Now the concept is that we have to transfer the data from input output devices to the memory. So it will take there is a 3 step for doing this. This is a program input output, interrupt initiated output and direct memory access. This is, we can say, I told you that binary information received from external devices is stored in the memory. Information transfer from central computer into a external device originating in the memory unit. CPU merely execute input-out instruction, may accept data temporary, but ultimate source of destination is in the memory unit. Data transfer between the central computer and input-out devices may be handled in the variety of the mode. Some mode use CPU as an intermediate path, other the data directly to and from the memory. So based on this, data transfer is from peripheral can be handled in the 3 ways: program input output and interrupt initiative output and direct memory access. You can say in program input output devices, what is that? Program CPU repeatedly check कि input output devices is ready or not. It means CPU, the CPU is very costly and its efficiency is much faster than the input output device. Input output devices, but it is you can say it is waiting for the status, checking the status repeatedly. It means we are wasting of the time of the CPU, because input output devices are the slow. When data is received and we get the status from the input output devices that now I am ready to transfer the data or the receive the data, then flag, then it make the flag 1, otherwise CPU will repeat it. Now the CPU read the register, transfer the data memory and operation. If operation is completed, then with the continue with the program, earlier CPU is working on it. Otherwise, it will go for the register for reading this and checking the flag. Other data is coming on it. So now you think that for transferring the data, we are wasting the time of the CPU, because in the meantime, when CPU is waiting for the data, it may be utilized in some priority work. So overcome of this issue, we come with another technique, interrupt input output, in which now the duty of the device is to send the interrupt. Basically, you know the interrupt is basically a concept कि if CPU get an interrupt, so it hold the current working process and transfer the control to the requesting devices, which initiate the interrupt. So in this case, it is the responsibility of the input-output devices, that when the device is ready to transfer the data, so it will send the interrupt to the CPU. It will now, in this case, we somehow manage the CPU time. The CPU is during till that the interrupt is received, then he will do some priority work. So now in this way we are saving some time, but still CPU when get the interrupt, after that CPU will take care of all the buses, data bus, address bus, control bus, and transfer the data from peripheral devices to the memory unit. So it means still CPU is working for transferring the data from peripheral devices, input-output devices to the main memory, or you can say main memory to input-output devices. Know how it is better than the program input-output, but still some part we are using the CPU. So now question is that we have to do some extra efforts so that we can utilize the CPU in much more efficient way. Then much more efficient way, so then come picture is the DMA. Then come is the DMA. Transfer of data under programmed input-output in between the CPU and peripheral in direct memory access. The interface data into and out of the memory unit through memory bus. The CPU initiated the transfer by supplying the interface with starting address, number of address needed to be transferred, then proceed to the execute of the task. It means, what this means? Means DMA, in case of the DMA hand over his responsibility, CPU can handle his responsibility to the DMA with telling him where the data he has to be taken. It means starting address. You know that this is the memory, and there is a starting address of the memory, and telling how much word it will transfer. Suppose 1, 2, 3, 4, 5. 5 words to be transferred. So it is telling, and also telling it is a read-write operation. We have to be read or we have to be write in the memory. So telling this information, he transfer his rights of working to the DMA. So in this way, the keep and interface meanwhile keep monitoring the device. When interface defines that device is ready to transfer it, this is in this way you can say DMA. I told you that CPU hand over his control for transferring to the DMA. So the CPU merely delays its memory operation to allow direct memory, since peripheral speed is usually slow and processor speed. Input-output transfer are infrequent compared to the process of the memory. In this, these are the drawbacks of the program input and interface. In this case of DMA, CPU is totally free after handovering the buses to the DMA. So now we can understand what actually how it works it way. So you can say, I told you that when control is transferred to the DMA, so what the CPU do? Address register. It means address register contain the address, specified the desired location. What I told you? I told you this starting position. Word count register. This word count register क्या है? Hold is to number of the word to be transferred. Control register, what is it? Specify the mode of the transfer. So it means, and now in this case you can say there is a bus signal, address bus, data bus, read, write, bus request, bus grant. So these are the portion, as you know, address bus, so the address of the address where the data is written, and what the control, if we want to read the data from the memory, or we have to write the data into the memory. These are the BR means bus request, means if DMA requesting the control of the bus, then it will send the bus request. After CPU, after doing some task, then it will grant the bus grant. It means it will transfer the control of these bus to the DMA. Now, where is the, you can say, this is the address bus buffer, data bus buffer, these are all. So it means, and this is DS and RS. It means DMA select. First of all, DS means DMA select, and RS means register select. Register means address register, word count register, control register. So these block diagram, the control show the what the DMA has in this, and this DMA request and DMA acknowledge means when the input output is ready to transfer the data or receive the data, it send the request to the DMA. Okay, it means I need your so I am ready. Now you can transfer the data into the memory. So now we can think we come in the these are some terminology: brush transfer and cycle transfer. Recycle. As you know, I say that is the memory, and there are the word 1, 2, 3, 4, 5, 6. If we want to transfer all this block, when we transfer the data block wise, yeah, you can say we transferring the massive data, bulk data, then we use the brush transfer. If we transfer word by word, means first we transfer this, then we transfer this, then we transfer this. It means we are transferring the data word by word. So this is called cycling mistake. And you can say if a block sequence consisting of memory word is transferred in continuous burst, then DMA control is master of memory bus. And this mode of transfer is needed for the fast devices such as magnetic disk, where the data transmission cannot be stopped or slowed down until the entire block is transferred. Cycling stealing क्या है? Alternative technique called the cycling stealing allow DMA controller to transfer one data word at a time, after which it must return control to the bus to the CPU. It means, now this point should be understood. In cycle stealing case, each word after transferring this word, one word, we have to be hand over the control of the buses to the CPU. Again, for second word, we have to again ask the control of the bus. But in case of the bus transfer, whole block is transferred. After finishing of the whole block in this each word in the block, then it will hand over the control to the CPU. This is the, and these are the terminology. The B0 means CPU can communicate with the DMA register. B0, CPU have left the buses and DMA can continue directly. मतलब bus grant, as you know, if control in simple way you can say, if the control of the buses are with the CPU, then the BG signal is 0. Or when the control of the bus is with the DMA and CPU is doing some other work, then we can say the big grant is 1. So now we understand the why we use the DMA. So how it's work on it. So you can say this is a one way of the block diagram. So you can understand that how you can say how we understand this, completely understand this way. You can say this is input output process. Input output process, peripherals, request for the DMA. When DMA get the request that output device is ready for transferring the data, input output device and peripherals are ready for the data. So it will send the bus request to the CPU. Means DMA asks CPU that I need the bus control. Please give me the control of the buses, because you can say the read, write, address and database, read, write and address of databases all are commonly connected with the DMA and the CPU. Read control, write control, data, address bus, all are connected to the both. So then CPU, what the CPU do? When he get the bus request, then CPU tell the CPU tell the DMA. One is the first it select the DMA, DMA select, and also tell the address select. By address select also it tell that from where, which address, from which starting address. I told you which starting address. You can say this 1, 2, 3, 100, 200, 300. Which address of the memory we have to be read the data. Then now we know the address and how much word, kitna, how much, how many words, through 2 words, 3 words, 4 words we have to be read, up to which Suppose we say we have to read 8 words. We have to read 8 words. Then second is, what we have to do? We have to read or write. Suppose we have to read from this location, this 8 words. These three things give the information by CPU and which input-output command. CPU release the input-output command in which is tell from which port we have to transfer the data, from where, which starting address we have to read, how much data, how many words we have to read, and we have to read or write which control. All these things are tell the CPU in input output, or these informations are stored in the registers. There are 3 registers I told in the previous slide. There are 3 registers. After then, bus grant signal is given to the DMA. Now, CPU hand over all the buses control to the DMA. And DMA acknowledge input-output peripherals devices that now I am ready to take or send the data. Now, these DMA requests send the data to the memory or read the data from the memory, whichever the operation is. So, these the way to actually it's how it's work. This is the concept of burst cycle and steal cycle, because CPU input-output peripherals are the very slow devices. So, they use the buffer also. Here is the buffer. Or these buffer size, based on these buffer size, we decide that is a burst cycle or steal cycle. If the buffer size is small, so we transfer only word by word. If buffer size is big, then we send the bulk of the data. When we transfer the bulk of the data, then it is called burst cycle, or when transfer the word by word, then it is called steal cycle. So, there is a concept that DMA is better perform in which? DMA better perform in the burst cycle. After sending or receiving, reading or writing from the memory, or into the memory, then finish, if transfer of the data is finished, then DMA send the interrupt to the CPU. Send the interrupt to the CPU and saying that I have finished my work. Now take the control of the address line, data lines, buses to you. So immediately he removed the BG, grant permission is removed. Now BG becomes 0 and this acknowledgement signal is also finished. So this is the complete cycle of the DMA, how it's work. And it is a very important topic for the point of the university exam, and hope so you should I hope you should learn this thoroughly, and thank you so much.